Welcome to Study Loop.
So here we can, for part A, we can use the condition in equation 3344. Here, the condition required in the critical angle calculation here would be that the angle sub theta sub 3, the angle measure sub 3 would be equal to 90 degrees. So this would be the condition for equation 3344. Thus, with here we know that theta sub 2 is equaling the critical angle, and we can simply say that according to Snell's law of refraction, n sub 1 theta sub 1 equals n sub 2 sine of theta sub 2, and n sub 3 equals sine of theta sub 3. Therefore, theta sub 1 would be equal to arc sine of the refractive index sub 3 divided by the refractive index sub 1. This is equaling 54.3 degrees. So we find theta sub 1 equals theta equals 54.3 degrees. This would be our final answer for part A. Now for part B, if we were to reduce theta, this would lead to a reduction in theta sub 2. And if we're reducing the angle sub 2, it becomes theta sub 2 becomes less than the critical angle. And if that occurs, there will be some transmission of light into material 3. So for part A, the answer is yes. For part C, we know that here we're going to note the complement angle of refraction is the critical angle. So we can say complement of the angle of refraction in material 2 would be equal to, rather we can just say is equal to the critical angle. And given this, we know that n sub 1 sine of theta sub 1 equals n sub 2 sine of theta sub 2. And so this would be equal to n sub 2 times the square root of 1 minus, here it would be n sub 3 divided by n sub 2 quantity squared. And so this would simply be equal to the square root of n sub 2 squared minus n sub 3 squared. And we can then say that theta would be equal to 51.1 degrees. This would be our answer for part C. And finally, my apologies. This would simply be theta, and then this would be the critical angle. Theta sub, my apologies. And finally, for part D, we know that reducing theta now would lead to an increase of angle with which the light strikes the interface between materials 2 and 3. So here it becomes greater than the critical angle. And of course, if that's the case, there will be no transmission of light into material 3. And so your answer for part D is no. No transmission of light into material 3. That is the end of the solution. Thank you for watching.